All right, AP Calculus. Today we are looking at variables other than x and y and the potato problem. So you want to get the notes that look like this, and we're going to look at variables other than x and y and then the potato problem. Okay, so we did these notes already, and just a note that this slide right here, these are on the worksheet you'll be receiving, so make sure that you take a look at that again. Okay, so we did all of this, and then we're starting today with variables other than x and y, which just get tricky. They're weird to look at, but you just have to be careful to know which is which. And so we look at ds dt, which is normally dy dx, and therefore the s is going to act like our y, and the t is going to act like our x. And most likely, if you have variables other than x and y, one of them is t, which works like your x. So t and x typically go together. So we're just going to follow our same process where we multiply both sides by dt so that we can get that off the bottom there. And we get ds is equal to 2ts squared dt. And so we need to move that s, so we're going to divide by s squared, divide by s squared, and then we want to write this as 1 over s squared ds equals 2t dt. And then so that's the separation of variables. Then we're going to integrate both sides. And we're actually going to write this left side as s to the negative 2 ds so that we can just do a regular old power rule. So the integral of s to the negative 2 is negative s to the negative 1. And the integral of 2t is t squared plus c. Okay, so first was separation of variables. Next is integrate both sides. And then next we're going to find c at where we negative 1 half. So again, we need to look at this point and know that this means t is negative 1 and s is negative 1 half. So we want to find c at the point negative 1 half. So we're going to plug that in. That's negative 1 half to the negative 1. That's a lot of negatives. Equals negative 1 squared plus c. And so negative 1 exponent flips whatever's inside. So this becomes negative 2 equals 1 plus c. So c is 1. And then our last step is to plug in the c and solve for y, or in this case, we're going to solve for s. So we have negative s to the negative 1 equals t squared plus our new c is 1. And then I would rewrite this as 1 over s. So negative 1 over s is t squared plus 1. I'm going to divide everything by negative 1. So we get 1 over s equals negative t squared minus 1. And then multiply s to the other side. So we get s equals 1 over negative t squared minus 1. If I did that too fast, little side note here, this is, we're going to multiply by s, so we get 1 equals negative t squared minus 1 times s, and then divide by negative t squared minus 1. And so there we have it. Okay, now we're going to go into the potato problem, which is an incredibly challenging problem from 2017. Average score on this, total points is 9 points. The average score on this was a 1.54. That's how difficult this problem was. But I want you to look at it today and realize that we could do this. You could totally do this problem, or at least a good chunk of it, and get way more than 1.5 points on it. Okay, so first, we want to read the problem and know what we're talking about. So at time t equals 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature is 91 degrees Celsius at time t equals 0. So the potato starts at 91 degrees Celsius. And the internal temperature of the potato is greater than 27 for all times t equals 0. So why is it always going to be greater than 27? because this is about room temperature, I'm assuming. So it's going to start at 91 degrees, and it's going to cool off until it gets to room temperature, which is about 27 degrees. All right, so the internal temperature of the potato at time t minutes can be modeled by the function h. So h is our temperature that satisfies this differential equation. So this differential equation here, this is the derivative of h. So this is our rate that our temperature is changing. So it's the rate of the temperature changing in degrees Celsius per minute. Okay, and then h of 0 equals 91. That's just our starting temperature is 91. So part A says, write an equation for the line tangent to the graph at t equals 0. Equation of a tangent line, we've done a million of these, right? So you take the slope, you take the point, you write the equation of the line. So our point that we have is 0, 91, and our slope comes from the slope formula or the derivative. dH dt is the slope formula. We want to know the slope at the point 0, 91. And then we have to make sure we know what those letters mean. It's when t equals 0, h, the temperature, is 91. So dH dt is negative 1/4 h minus 27, so 91 minus 27. And just note this would be a non-calculator problem, so you can get a feel for the type of arithmetic you'll have to do. So this is negative 1/4, 91 minus 27 is 64, and negative 1/4 times 64 is negative 16. So that is the slope, and the point is at 0, 91. So the equation of the tangent line is y minus 91, except it's not y. It is h. So h minus 91 equals negative 16 times t minus 0. Or we'll write that a little nicer. H minus 91 equals negative 16t. So there's the equation of our tangent line. And then the next part says, use the equation to approximate the internal temperature of the potato at t equals 3. So that's just saying to find h when t equals 3, not 0, 3. And so we're just going to plug in. So h minus 91 equals negative 16 times 3. H minus 91 equals negative 48. So H equals 43 degrees Celsius, which should make sense. Temperature starting at 91 degrees. After a while, it's going to drop down to 27 degrees. So somewhere at t equals 3, temperature 43 degrees would be logical. Okay, this next part I thought was really, really hard. In fact, I didn't do well the first time I saw this problem either. But we're going to look at it anyway and see if we could at least get partial points here. All right, so use the second derivative. That's what d squared h over dt squared means. Use the second derivative to determine whether your answer in part A is an underestimate or an overestimate. So first, if we're going to use this, we actually need to find it. So d squared h over dt squared is the second derivative. And we know that the first derivative, dh dt, is negative 1/4 h minus 27. And so we know if we want to take the derivative of that, we're going to do negative 1/4 h plus 27 over 4. And so the derivative of that is negative 1/4, and there's more, right? Because h is like y. So little side note, if we had dy dx equals negative 1/4 y plus 27/4, the derivative of that is negative 1/4, whoops. And when you take the derivative of y, you have to write dy dx. So negative 1/4 dy dx. So this is negative 1/4 dH dt, not just negative 1/4. And so dH dt is negative 1/4 h minus 27. And so we can write this as 1/16 h minus 27. So there's the second derivative. So hopefully we could get a point on that by getting the second derivative. And the next part I thought was hard, but I'll explain it. And if you missed that on an AP test, I would not be upset. All right, so we know that h is always greater than 27 when t is greater than 0, right? So for every time, we know that h is bigger than 27 because 27 is the room temperature. And if h is bigger than 27, then this second derivative here is going to always be positive. If h is bigger than 27, the second derivative will always be positive. So h is greater than 27 for all t. So the second derivative, d squared h over dt squared, is always positive for all t. And the second derivative tells us concavity. So if the second derivative is always positive, then the function h is always concave up. Okay, so the second derivative is always positive because h is always greater than 27. So the original function h is always concave up. And still, we don't know what that means. But in part A, we were taking our concave up curve, and we were using the tangent line at 0. So this is here at t equals 0 to predict at t equals 3. So the actual value here is right there on the curve, but we use the tangent line to predict, and so therefore the tangent line is on a concave up, it's always going to be under. And so since h is always concave up, the thing we got in part A is an underestimate. All right, and I'm not too worried about part B. However, we should be able to do really, really well on part C. Part C says for t is less than 10, an alternate model for the internal temperature of the potato at time t minutes is this function g that satisfies this differential equation, dg dt, where g is degrees Celsius, and we're at the same starting point of 0.91. Find g of t. This is our separation of variables. So we're going to rewrite that dg dt is negative g minus 27 to the 2/3. And so we're going to move our t over, our dt. So we have dt here. And then we need to move our g over. So I'm going to leave that negative because I know I'm creating quite a mess over here. So we're going to divide by g minus 27 to the 2/3. And so we have 1 over g minus 27 to the 2/3 dg equals negative 1 dt. And then we're going to integrate both sides. And I'm going to write the left side as a power rule again. So I'm going to write the integral of g minus 27 to the negative 2/3 dg equals the integral of negative 1 dt. Now this left side, you could do u substitution. So if you don't understand what I say here and you just want to use substitution off to the side, you can. However, since the derivative of the inside is 1, it's just power rule. So this is g minus 27, power rule, add 1. So negative 2/3 plus 1 is positive 1/3. And then divide by 1/3 or multiply by 3. That works because the derivative of the inside is just 1. If you want to use substitution, let u equal g minus 27, you'll get here the same way. All right, equals the integral of -1 is negative t plus c. All right, then we're going to plug in our point, which is 0.91. So we're going to find c by plugging in 0.91. So that's 3 g minus 27 to the 1/3 equals -0, 0 plus c. Oh, I forgot to plug in. So instead of g, we're plugging in 91 minus 27. So 91 minus 27 is 64. So we've got 3 times 64 to the 1/3 equals c. 64 to the 1/3 is 4. It's the cube root. So 3 times 4 is 12. So c is 12. And once we find c, our last step is to plug it back in and solve. So we'll have 3 times g minus 27 to the 1/3 equals negative t plus 12. And this looks messy, but we're just going to very slowly, one step at a time, unravel the g on the left. So we're going to divide by 3. So g minus 27 to the 1/3 equals negative t plus 12 over 3. And then 1/3 power means cube root, so we're going to cube both sides. So we're going to put both sides to the 3rd power. So we get g minus 27 equals negative t plus 12 over 3, and we need to do that to the 3rd power. And then we're going to add 27. So g equals negative t plus 12 over 3 to the 3rd power plus 27. So we have found g, and you would think we'd be done, but we are not. There was this extra line there. Based on this model, what is the internal temperature of the potato at t equals 3? And so we just need to find g of 3, which is going to be negative 3 plus 12 over 3 cubed plus 27, that's 9 over 3 cubed plus 27, that's 3 cubed, that's 27, plus 27, which is 54 degrees Celsius. And there you have it. So hopefully you could do well on that problem. So make sure that you understand all those details. Go back, rewind if you need to, pause. Make sure that you understand the algebra with that. And I will see you later.